The universe is a vast, dark ocean, and for ages, we've wondered if we're alone on its shore. We send our dreams and machines into the darkness, searching for a sign, anything to suggest we're not alone. Each discovery is a new shell on the beach, but sometimes we find something that looks like a footprint. Our quest to know our place in the cosmos drives our science and imagination. Today, with new tools, we peer deeper than ever before, and what we're seeing is challenging everything we thought we knew. Now, a new light has appeared. Not a star, not a galaxy, but something else, flickering with an unnatural rhythm. It's a beacon, a possible footprint on a distant cosmic shore. The journey to understand this new story is just beginning. To see the unseeable, we built the James Webb Space Telescope, humanity's golden eye on the cosmos. Unlike Hubble, JWST sees in infrared, revealing ancient hidden things. Its massive gold-coated mirror and sunshield let it capture faint, distant light, peering through cosmic dust. JWST can witness the birth of stars and planets, and even analyze the atmospheres of exoplanets for signs of life. Its instruments must be kept incredibly cold, shielded from the sun, Earth, and Moon. This telescope is 1,000,000 miles from Earth, an engineering marvel. Its mission, to look back to the dawn of time, watch galaxies and stars form, and, most tantalizingly, search for life. Now, JWST's search for technosignatures puts it at the forefront of our quest to find company in the universe. JWST turned its gaze to the R2 Swan nebula, a stellar nursery 1/500 light-years away in Cygnus. This swirling cloud of gas and dust is rich in organic molecules, the building blocks of life. R2 Swan's high concentration of these molecules makes it a prime target for astrobiology. Previous telescopes couldn't see through the dense dust, but JWST's infrared vision can. Astronomers aim to map the nebula's structure and find protoplanetary disks. They expected to see the gentle glow of a cosmic nursery at work. Instead, they found a sharp, concentrated, and strangely rhythmic source of light. The universe, as always, had a surprise hidden in the dust. As the James Webb Space Telescope's data streamed in from the far reaches of the cosmos, scientists at Mission Control noticed something truly extraordinary. A single brilliant point of light deep within the swirling clouds of a distant nebula. This anomaly stood out immediately, behaving in ways that defied all previous observations and expectations. It was unlike any known celestial object, and its presence sparked immediate curiosity and excitement among the team. It wasn't a star, nor was it a supernova. Instead, it appeared as a tight cluster of lights, eerily reminiscent of the way a sprawling city looks from orbit above Earth. Tiny, organized points of brightness scattered across the darkness, forming patterns that seemed almost intentional. When astronomers analyzed the spectrum of this mysterious glow, they found it didn't match any natural source they had cataloged. The light bore the unmistakable signature of something artificial, as if it were produced by technology rather than by nature. What made this even more astonishing was the environment itself. This was no ordinary planet or stable star system. The anomaly was located in a chaotic, turbulent nursery where new stars and planets were still forming, a place considered too hostile for life as we know it. For any civilization to not only survive but thrive in such a volatile region, it would have to be unimaginably advanced, capable of harnessing technology far beyond anything humanity has achieved. The research team meticulously checked and rechecked the incoming data, running every possible test to rule out error or interference. Each analysis confirmed the same result. The signal was genuine, and it was coming from a region known as R2 Swan. Even more intriguing, the light displayed clear patterns and periodicity, blinking and pulsing in a way that suggested a dynamic, controlled system, rather than random cosmic activity. This organized, complex behavior simply couldn't be explained by any known natural process. The formation and timing of the lights defied randomness, hinting at deliberate design. The only logical conclusion was staggering. This could be a technosignature, the first credible evidence of extraterrestrial technology ever detected by humanity. The implications of such a discovery were profound, challenging everything we thought we knew about life in the universe. The search for answers had only just begun, and the scientific world braced itself for what might come next. For decades, the search for extraterrestrial intelligence, SETI, has focused on listening for faint radio signals drifting through the cosmos. Scientists have scanned the skies hoping to catch a deliberate beacon, a purposeful message sent from another civilization trying to make contact. But as our own technology has evolved, so has our understanding of what to look for. Technology leaves behind many fingerprints, known as technosignatures. These can be anything from industrial pollution in a planet's atmosphere, to massive artificial structures orbiting a star, or even the glow of city lights shining on a distant world's night side. Detecting these artificial lights on exoplanets is an enormous challenge. The signals are incredibly faint and easily lost in the overwhelming glare of their parent stars. Most of the time, any artificial glow is simply drowned out, making it nearly impossible to spot with traditional telescopes. But with the James Webb Space Telescope's unprecedented sensitivity, astronomers can now attempt to isolate the faintest glimmers of light coming from a planet's night side, searching for signs that might hint at advanced civilizations. By carefully separating the planet's dim glow from the star's brilliance, we can look for patterns that don't occur naturally. But the R2 Swan anomaly stands apart from these subtle searches. It's not a faint hidden signal, but a direct, bright source of light shining from deep within a dark nebula, where no such light should exist. This makes the anomaly much easier to detect, but at the same time, it's far more difficult to interpret. What could cause such a powerful, isolated light in the darkness? To solve this mystery, scientists must rule out every possible natural explanation. That means building complex models, observing the region in multiple wavelengths, and always maintaining a healthy skepticism. The search for life beyond Earth is a painstaking process of elimination, where each possibility must be tested and retested. Every new clue, every anomaly, brings us a step closer to understanding the universe and our place within it. The R2 Swan signal is louder, brighter, and more mysterious than anything astronomers have encountered before. Now, the challenge is to unravel its secrets and discover what this extraordinary signal truly means for science and for humanity. With a discovery this monumental, skepticism is essential. Could this be a rare natural phenomenon? Gravitational lensing, a cluster of unusual stars, or a cosmic mirage? The nebula's complex environment could create optical illusions we've never seen. Instrument error is another possibility. Even JWST isn't immune to glitches. The team is planning new observations to rule out these scenarios. But if it's not a trick of nature or technology, it could be what it appears, a technosignature. If so, who are they? How did they thrive in such chaos? Are they still there? The light we see is 1,500 years old, a cosmic archaeological find. While natural explanations are more likely, we can't dismiss the possibility of our first cosmic neighbors. The universe may be whispering back. The R2 Swan discovery follows decades of searching and silence, the so-called Great Silence of the Fermi Paradox. SETI has listened for signals since the 1960s, but found only tantalizing false alarms. Meanwhile, missions like Kepler and TESS have revealed that exoplanets are common. There are likely more planets than stars. We've found rocky worlds and habitable zones, turning the search for other Earths into a real catalog. These missions tell us where to look, focusing our most powerful telescopes on the best candidates. The search has shifted from just listening to actively looking for biosignatures and technosignatures. Maybe the universe isn't silent. We just weren't listening in the right way. Now, with new tools and new clues, we're learning the language of the cosmos. The silence may be ending. If the R2 Swan signal is confirmed as a technosignature, it will end our cosmic solitude. The knowledge that we're not alone would ripple through science, philosophy, and culture. Human history would become just one chapter in a much larger story. Every telescope would turn to R2 Swan, searching for patterns, language, and meaning. It would ignite a new era of exploration and force us to ask, do we respond? What do we say? Who speaks for Earth? The discovery would unite humanity, making our divisions seem trivial. It would inspire a new generation to explore and understand our place in the universe. We would finally see ourselves as part of a cosmic community. We stand at a crossroads, on the edge of discovery, with the universe stretching out before us, vast and mysterious. Each night, as we look up, we are reminded of how much we have yet to learn, and how every new anomaly brings both questions and hope. Whether the R2 Swan anomaly is a natural phenomenon or something artificial, its presence has sparked a wave of curiosity and wonder across the globe. It has captured our imagination, igniting debates, dreams, and a renewed sense of possibility about our place in the cosmos. The journey to understand this mystery will push our science and technology to new heights. Our next steps are clear. Keep observing, look for changes, and collaborate globally, uniting the brightest minds from every corner of the world. This is science at its best, a transparent worldwide effort to pursue the truth, where every discovery is shared and every question is welcomed. The process will be slow, careful, and rigorous. Each piece of data will be scrutinized, every theory tested, as we work together to unravel the unknown. The James Webb Space Telescope is our vessel into the unknown, a marvel of human ingenuity, peering deeper into space than ever before. It brings us news of a mysterious new shoreline, revealing sights and phenomena that challenge our understanding and expand our horizons. It inspires us to keep pushing boundaries, to ask bigger questions, and to dream of what lies beyond the next discovery. We are building tools for future explorers, nurturing the next generation of scientists, engineers, and dreamers who will continue this journey. As we await more data, our anticipation grows. Each new observation could bring answers, or even more profound mysteries. Let's remember, the universe is dynamic, surprising, and full of stories waiting to be told. Every night, the cosmos writes a new chapter. The lights in R2 Swan remain an enigma. Perhaps a cosmic coincidence, perhaps a sign of something more, a puzzle that invites us to look deeper. Perhaps it's a greeting from afar. Either way, these lights have changed the conversation, inspiring new questions and new collaborations. They have moved the question, "Are we alone?" to the very forefront of science, making it a central quest for our generation. The next chapter of humanity's story is being written in the stars, and together, we are turning the page to a future filled with wonder and discovery.